Welcome to our next video in this course as we continue our series looking at topics in chemistry and using the approach of an inquiry type of style. So we're going to continue to use these inquiry activities, and this time we're going to be talking about ions. If you recall, we already talked about atoms of an element that can vary a little bit, and it is the number of neutrons that can vary to make isotopes. It's still the same element, still has the same number of protons, and today we're going to learn that the number of electrons can vary as well. So just a quick review, we have already learned that not all atoms of an element are the same. That's not to say that it changes the element, doesn't become a different element. Remember, it is the atomic number, the number of protons, that is the ID, the identification number for that element. But there are variations in the number of neutrons. If the number of neutrons changes, then we create what are called isotopes. And those isotopes have different masses as well, because it is the neutron and the proton together that give you the mass of that particular isotope. Now, in this activity, we're going to look at, as I just mentioned, another variation, and that is the number of electrons. So an atom can gain or lose electrons, and when it does so, it's going to create a charged particle, and those charged particles are called ions. So this exchange, it's very common. In fact, it is so common that is how we get bonds, a certain type of bond that is created, and it is a common way for a chemical change to create new bonds. Old bonds are broken apart and new bonds are made. And in that process, we have a chemical change, a chemical reaction. Okay, let's explore just a little bit this model. This would be model 1 right here. And as we do so, there are going to be some questions that are going to progressively get more and more maybe difficult as we start with some observations and then lead into some applications and learn a little bit about this topic of ions. So here you'll see model number 1, and it's important to just make note of a few things here. You'll notice we have atoms and ions. So we're going to be looking at the atoms, and then we're comparing it to the ions of that particular element. So we have a symbol here. Remember from our last discussion that we have the symbol of the element. In this case, it's Li for lithium. This raised number on the left is going to be the mass, and that is the number of neutrons plus the number of protons. And the bottom number is the atomic number, which is the number of protons. Okay? You'll notice now we have another number right here on the right, and it's slightly raised as well. And it is going to be a number and then a plus or a minus. You'll see there's a minus over here. That is actually the charge on that particular particle. And so just make note of that, and we'll mention it as we move forward. Here's an atomic diagram. What they're doing is they're trying to show you the atomic level, a diagram or model of what it might look like at the atomic level. They're showing you here that we've got the electron cloud. That is the region around the nucleus where you're going to have the electrons residing, and they're noted there by negative signs because an electron has a negative charge. And then enlarged here, they've taken this nucleus right here in the center of the atom and enlarged it. They're showing you what's inside of the nucleus. Those would be your neutrons and your protons in there. The protons have the positive sign. The neutrons are the blank circle. They are then going to note the number of protons, number of neutrons, and number of electrons for that particular atom or ion. You'll notice it says here neutral atoms, and then ions. Remember, these are the charged particles. Those are charged because they've either lost electrons or gained electrons, so that it has a positive or negative charge on it. So this is going to be given to you here, and it is given to you for lithium, fluorine, oxygen, magnesium. We have down here aluminum and nitrogen. Okay, so now that we've looked at the model, let's go back to the questions and let's fill in some of this information. Is the number of protons the same in the atom and the ion? So we're going to be looking at each of these. As I mentioned, we've got 6 elements here, and we're going to be answering these questions. Is the number of protons the same in the atom and the ion? So we're looking at protons here. Please be careful when you read this. Protons, here says is the number of neutrons the same, and is the number of electrons the same? And we are comparing what? The atom and the ion for each of these. So we could answer all of these right now, probably. Let's go ahead and look through these. We're comparing the atom to the ion for each of these elements. So let's first look at the number of protons. 1, 2, 3, 1, 2, 3. Yes, protons are going to be the same. Neutrons, 1, 2, 3, 4. Neutrons, 1, 2, 3, 4. Yes, they are the same. Electrons, 1, 2, 3. Electrons over here for the ion, 1, 2. Okay? And that's going to be the same for all of these elements. They're just driving home the idea that when you change the number of electrons, which can change, you're not changing the element. You're only making it a charged particle. So the same thing is true for fluorine, oxygen, magnesium, aluminum, and nitrogen. It's going to have the same number of protons for both the atom and the ion, same number of neutrons for the atom and the ion. It's going to be the number of electrons that are different. In this case, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can go ahead and answer this question for all of these. Protons are all the same. Yes, 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 and yes. Number of neutrons the same. Yes, 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 and yes. And here it is the electrons that they are making sure you understand is the subatomic particle that is changing. And let's look here. We're trying to identify, are these metals or non-metals? Let's look back at our diagram or model here. You may or may not know which of these are metals and non-metals, so I'll give you a hint. The metals are going to be located on the left side of the periodic table, and the non-metals are going to be on the right side of the periodic table. So lithium, if you find it on the periodic table, you will find it on the left side. Lithium, magnesium, aluminum are all metals. Fluorine, oxygen, nitrogen are all on the right side of the periodic table. They're all non-metals. So let's go ahead and fill that in. Metal, metal, metal. It's going to be a non-metal, non-metal, and non-metal. So based on the table that we just completed, what distinguishes a neutral atom from an ion? So a neutral atom or an ion, and it is going to be the number of electrons. So neutral versus an ion. An ion is a charge, by the way. It is going to be the number of electrons. Number 3, examine the isotope symbols in Model 1. What is the ion charge located, or where is the ion charge located in the isotope symbol? And I kind of mentioned this already. So like for lithium, you would see there's a little ion charge raised and kind of upper right, and you might see a 1 and then a plus. Usually the plus or minus sign is written after the number. So lithium +1 or magnesium with a +2. And you don't necessarily have to write the atomic mass and the atomic number. You may just see the ion written just with the charge alone, like that raised number to the right of the symbol. And you'll notice that you're given all of the charges right here for each of these elements. Is a charge indicated on the neutral atom? No, there is no charge. If you just see Li, it is understood that it is neutral. You have the same number of protons. Protons, number of protons equals number of electrons. These are your two charged particles in your atom. Positive protons, negative electrons. If you have the same number of both, then it's going to be neutral, and there's no charge written on the element symbol. Okay? Which subatomic particle carries a positive? We already mentioned that. That would be your proton. And the negative would be your electron. Propose a mathematical equation to calculate the charge on an ion from the number of protons and electrons in an ion. Confirm that your equation works using 2 positive ion examples and 2 negative ion examples from Model 1. So if you have number of protons and electrons, then you're going to have to figure out how to to determine what the charge is. Well, simply, if you have more protons than electrons, the difference between those is going to give it a positive charge. And if you have more electrons than protons, the difference is going to give it a negative charge. So you got to find the difference first, and then one or the other is going to give you the positive or the negative. Okay? So you could just write something like this. You have the number of protons minus the number of electrons is going to give you the charge on your particular atom. If the number of protons is greater than the number of electrons, it is going to, if P is greater than E, then you're going to have a positive charge. If the electrons are greater than the number of protons, then you're going to have a negative charge. Okay? Chemists refer to positive charged ions as cations. So here's just some vocabulary. Cations mean it is positively charged. An anion means it is negatively charged. I just remember this because cation has a T in it. Looks like a plus sign, so that helps me remember positive is cation. Anion, you might see the prefix there, kind of like being the opposite of or anti. So anion would be a negatively charged. Okay? Let's fill in this following table here. And we have enough information. You'll notice that what we have here is you're going to be either given a symbol, and from that we can determine all this other information, or you might be given some of the numbers of the subatomic particle and then fill in the table from there. So we now have 3 subatomic particles that we should know all about, and we should be able to figure out what their relationship is given information about the atomic mass, the atomic number, and the charge on that particular atom or ion, I should say. Okay? So let's start right here. Let's look at this symbol and let's just make some observations. 88, remember that is your mass. Remember that is protons plus neutrons. And then down here we've got the atomic number. Atomic number, remember that is the number of protons. And now we have something new. We have a new number here, plus 2. Or if there is no number, remember that number would be 0. We don't write it. That plus 2 right there is telling us the charge, which is basically telling us protons minus electrons. And that's giving us our charge here. So from those 3 numbers, we should be able to figure out number of protons, number of neutrons, and number of electrons, which is what we're asked to do down here. Atomic number, 38. Mass number, 88. Let's come down here. Cation or anion. Anion or cation, it is a positively charged, so it is cation because it says 2 plus there. Number of protons, electrons, and neutrons. Now we can get into the specifics of how many of each of these subatomic particles. Let's start with protons because that's the easiest. It is the same as the atomic number, 38. Number of electrons is going to be, since it's 2 plus is our charge, we have 2 more protons than electrons. If you have 2 more protons than electrons and the number of protons is 38, then the number of electrons must be 36. The number of neutrons, if the total mass is 88 and the number of protons is 38, then you must have 50 neutrons. Now you try, if you haven't already, I hope you've done this activity completely, but if you haven't already, you can go ahead and pause the video right here and do the next column and the 3rd column and the 4th column, and then restart the video and see how you do. Okay? So atomic number, 16 is the bottom left number. The mass number is 32. I know that if I subtract those two numbers, I'm going to get the number of neutrons, which is going to be 16 as well. And the number of protons is the same as, the atomic number. And the number of electrons, since this is a 2 negative, it is an anion with a 2 negative charge. That means it has 2 more electrons than protons. And since I've got 16 protons, I must have 18 electrons. Mass numbers 70, 31, 28. They're giving us now some numbers here of subatomic particles, or the mass number, and then we have to figure out what the symbol is and the number of neutrons. So this, if you look on your periodic table, here's how you know what element it is. All you have to look at is a number of protons. Look on your periodic table, find the symbol that has an atomic number of 31. Look at that symbol. That symbol is going to be sulfur, capital S. So we are going to put our, that was this one over here. My apologies. That is Ga, okay? Ga, and we're going to put the atomic number down here. The mass is upper left, and the charge is going to be right here. How do I know the charge, by the way? Let's just review. Our atomic number is going to be the same as the number of protons. And the number of electrons, you'll notice, is 3 less than the number of protons. So we have 3 more protons than electrons, giving it a positive 3 charge. That makes it a cation. And the number of neutrons, how do we know that? Well, we take the mass number, which is neutrons and protons together, and we subtract the number of protons. So that is going to give us a total of 39 there. Okay? Let's continue. We'll do one more here. Atomic number, look on your periodic table. 35 is the atomic number for bromine. And the mass number is going to be the number of neutrons and the number of protons together. So that would be 35, and 45 is going to be our 80. And then we have here the charge on this, since we have 36 and 35, that's going to be a -1. And sometimes you don't have to put the 1 negative, just a negative alone will take care of that. That's a -1 there. And that means it is an anion with a charge of -1. Our symbol, if I was to complete this here, remember we put the atomic number down here, 35, and we put the mass number up here of 80, and there's our charge of -1 written. Okay? So let's continue and let's look at these questions right here. Could a 3+ ion of aluminum be made by adding 3 protons to an aluminum atom? Explain. Alright, well, if we have an aluminum atom, let's look back here at the model just for a second, just so you can get your bearings. An aluminum atom has 13 protons. That's its atomic number right there. It's given to us. Number of protons. If you take an aluminum atom and you add 3 protons. If you take an aluminum atom, which we just said has 13 protons, and you add 3 protons, I'm going to add 3 protons. Now it is going to have an atomic number of 16. That's no longer aluminum. That's a different element. If you look on your periodic table and find out which element has an atomic number of 16, you'll see it's not Al anymore. You can't change the number of protons and have the same element that you did before. That is for a completely different element. So it's asking, could you take a 3+ ion of aluminum, and can you make a 3+ ion of aluminum by taking a neutral aluminum and adding 3 protons? No, that's not how you get a charged ion of aluminum. The way you get Al3+ is by taking away, removing 3 negative electrons. The only way you make charged particles is by adding or subtracting electrons. You never take away protons if you want to keep the same electron but just give it a positive or negative charge. If you have different number of protons, you will not have the same electron or same element anymore. Okay? So the answer here is no. No, 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 no. That's not how you make charged particles for a particular element. You always make a cation or an anion by removing electrons. You have to remove electrons, keep the number of protons the same. Now you have a charged atom for that particular element. Okay? Number 9. One of your classmates is having trouble understanding ions. Explain the formation of a cation like, he explains the formation of a cation like this. When you add an electron, you get a positive charge because adding is positive math. Well, you have to understand though, what you're adding is a negatively charged particle. Okay? So if you add a negative value, like if you add a -3, that is the same thing as subtracting 3. Simple mathematics, right? So a better way to describe this would be if you are adding negative electrons, let's say you add -3, that is equal to subtracting 3. Okay? Or if you take away electrons, if you subtract 3 electrons, that is the same thing as adding 3. Subtracting negative is like adding a positive. Okay? So the key here is that you have to remember to form an ion. Ion is formed by loss or gain of electrons, and only electrons. That's how ions are formed. Remember, isotopes, we're adding or subtracting, gaining or losing neutrons. That changed the mass. Adding or subtracting electrons is going to change the charge. But you never change the protons. Otherwise, if you have different number of protons, it's a completely different element. Okay, it's not an isotope or an ion of that element anymore. Okay. If we look now at model number 2, this is the kind of abbreviated, it's an abbreviated periodic table. It's not showing all of your elements. It is just showing certain groups. But it is it's enough for us to kind of draw some conclusions. So you'll notice here in this periodic table that on the left side of our periodic table, we have our cations, and these are your metals. These are your metals right here. All of these are metals on the left side. And over here, we have nonmetals. That is crucial for you to know because we're going to be revisiting that often. You will notice that the metals form cations. They predominantly want to lose electrons. That's what they like to do, and we'll talk about why that is later on. But I'm just setting you up right now to let you know that metals over here on the left side of this periodic table, they like to form positively charged ions by losing electrons. Over here, your nonmetals like to form anions, and they do that because they like to gain electrons. Well, maybe you kind of see where this is heading. If you've got metals on one side that like to lose electrons, nonmetals on the other side that like to gain electrons, chances are that might help them form bonds. We'll talk about that later on. Number 10 says, draw a stair-step line in Model 2 to separate the metals and the nonmetals. Well, more or less, these are going to go right here. Now, I know there's some blanks, but more or less, the stair-step line is going to go right here. And you're going to have metals and nonmetals kind of along that stair-step line. On the right side of the stair-steps, you're going to have nonmetals. On the left side, you're going to have metals. Consider the ions listed in Model 2. So we have ions that are filled in. By the way, this is the location. What they're saying here is this is the location for oxygen, the symbol oxygen on the periodic table. If it forms an ion, it is most likely going to form a 2+ ion. So they put the ion charge on there for oxygen. Oxygen can also be a neutral atom, don't get me wrong. It can just be O, But if it's going to form an ion, it is predominantly going to form a 2+ ion. So they put that right there in the same place as oxygen on the periodic table. Aluminum, there's where aluminum, the symbol aluminum is on the periodic table. Yes, it's a neutral atom, but if it forms an ion, it is predominantly going to want to lose 3 electrons and form Al3+. Okay? So, in general, do nonmetals form anions or cations? Nonmetals over here are going to form your anions. They like to gain electrons. Okay? In general, do metals form anions or cations? And they form cations because they like to lose electrons. Loss of electrons. Which nonmetal appears to be an exception to these guidelines? Well, you have a nonmetal, and that would be hydrogen. Hydrogen is kind of an exception to the rule. It is, and we will talk about this later on when we talk about electron configurations, but hydrogen, even though it's a nonmetal, it's a gas at room temperature, and it is many times acting like a metal in that it will lose an electron and bond with a nonmetal, just like many of these metals will over here. So hydrogen, just keep in mind, hydrogen is kind of an exception to the rule for nonmetals. It can, often will, lose an electron to make a +1 ion and bond with nonmetals, acting itself like a metal. Let's wrap this up. Extension questions. Name the family of elements that make -1 anions as shown in Model 2. So I'm going to give you just some names of groups of elements, and those groups are going to tell you a little bit about a property that is common to all of those in that column or family or group. On a periodic table, when you look at a column, everything in this first column, that's called a group or a family. Everything in this second column, that's a group or a family. And you'll notice that all of the metals in this first group form +1 ions. Everything in the second group form +2 ions. That's not a coincidence. Okay, we'll talk about this. Everything over here in this group with fluorine and chlorine, that group, everything in that group are going to form -1 ions. Everything in this group form -2 ions. And you're going to see a pattern there, and we'll talk about why that is when we talk about electron configurations. So, back to our question number 12. Name the family of elements that make -1 ions in Model 2. That group is called, everything here is fluorine, those are called the halogens. These are the halogens right here. Okay? Name the family of elements that make the +2. That is on the opposite side of the periodic table, right here. And those are called the alkali earth metals, or alkaline, I should say. For the main group of elements, excluding the transition elements, it is necessary to memorize the type of ion each element makes, or could you predict the ion charge using the periodic table? So they're asking, is it necessary? Okay, let me just show you what they're getting at here. Basically what they're saying is, if you look, everything in this first column is going to form a +1. You could just memorize that. Everything in the second column is going to form a +2 ion. We're going to jump over the transition elements because there's some variety here. Notice it's not always the same. Everything in this third main group, when they say main group, they're excluding this middle section here. Main group is just everything minus the transition elements. Okay, or you could say it's the 13th group if you want to. Everything here is going to form a +3. Let's go to the other side, the opposite side. Everything in the 7th or 17th group, sometimes, this here is going to form a -1, here -2, here a -3, and this group right here, well, there's some variety. So it could be +4 or something else, but these are very consistent, very consistent. So all you have to do is realize that at either end, you've got a +1 and a -1, and then just move your way in by going from +1 to +2 to +3, -1 to -2 to -3, and then we'll worry about these middle ones later on as we look at the different possibilities that they form, the different possible ions. But the main group is really very consistent, okay? By the way, this 8th group right here, those are called the inert gases or the noble gases, and they do not like to form ions at all. They're very stable. So you'll see there's no charge here. They resist gaining or losing electrons. But the other ions, you should know, you should memorize, excuse me, you should memorize these 3 groups here and the ions that they form, and these 3 groups right here and the ions that they form. Those should be memorized. Okay? So the whole point here is that you don't have to necessarily memorize them. You just have to realize that you're starting with -1 and +1 at either end, and then counting inward. All right? And in Model 2, there are several elements whose atoms make more than one type of ion. Where in the periodic table are these elements usually found? And I kind of alluded to that already. These transition elements right here in this area, including a few over here, are going to have multiple ion possibilities. And we won't get into that. Why? We'll talk about that later on when we talk about electron configurations and those valence electrons. Okay? So the important thing here is to remember that ions are formed by gaining or losing electrons. It is the electrons that determine the number of electrons as compared to the number of protons that is going to determine the charge of that particular atom, that particle. Okay? Excellent. We will continue in the next video, and I hope this was helpful. We'll see you then.